Hey guys, welcome back. So what we're going to do in this thing is have the enemies fire every single frame at the player's feet for now in a very amusing snake-like fashion. The projectiles will have a customizable velocity on them, and then also what we'll find is that the projectiles themselves have a damage value on them that here can be set by the enemy, so he can override the amount of damage on the projectile. They have like a root damage, and then they also have a damage that gets overridden by the enemy, so we can customize how much damage each enemy does with each projectile. Okay, I'll see you in there. Let's start this video with a recap of unit vectors, speed and velocity, and also just give you the general plan for how this is going to work. So I'm going to zoom in fact I'll spin round to keep the other enemies out the picture, have the nice castle in the background, and imagine that the enemy on the left is shooting the player on the right hand side here. Okay, just going to move that player down a tad so he's on the ground. Okay, so the player's root transform is sitting here at his hip level, and that's fair enough as a destination for the enemy's projectiles. What we're going to do, by the way, in this section for now is we're going to make the projectiles come out of the enemies, not the player. So I'm actually going to move the projectile from the player to the enemies. Player's going to be melee only for this section by a recognized decision, and the enemies are going to be ranged attack only for this section. So we can focus on tuning that type of combat. We'll still have loads of diversity. So what we're trying to do is get a projectile, probably a slightly smaller projectile than this. Let's just bring this projectile right above this dude's head just for visualization, and make it a bit smaller. Just instantiate yourself a projectile, scale it right down because right now that thing's crazy. And I'm just going to focus back in on this enemy here. Double click, remember, can focus in, and the projectile's roughly above his head. And I'm going to explain what we want to do. So we want a projectile, big and visible and simple. And what we want it to do is to go from the enemy, from this position above his head for now, because we don't want it to accidentally hit the enemy, just as a starting point, it's going to go from above his head. And then we want to hit the player just in his root. Later on, we can customize the hit points and stuff. Let's just keep this real simple. So let's talk about the vectors involved in this for a second. So I'll do a screen sketch using Windows handy tool here. And I'm going to make it, let's say, a light purple. That should show up against all the colors we've got. So what we need to do is, this is the point that we're going to be hitting. We're just going to take the player's root position. Remember, we have the player inside the enemy as a game object, not as a player, but as a game object. And then this is going to be some sort of spawn point which we'll create on the enemy. So the first thing we need to do is work out a unit vector from the spawn point in the direction of the player's root transform here. So not actually as long as, don't worry about the length for the moment, but we want a vector of length 1, which just tells us the direction, and that's what we call a unit vector. I can probably make this a bit more visible. I'm trying to find a color that's going to be really going to show up. Maybe this green here. So a unit vector here of length 1. That's one thing we want to do, and that's in the direction from there to there. And then what we want to do is we want to have some sort of projectile speed. And then what the speed does is it's a multiplier on that vector. So if the speed was to say equal 10, then what we would do is we'd have a total length here of 10 from there to there. So remember, velocity is the direction plus the speed and the speed. So it's an arrow, ultimately a vector ultimately of length 10, and the direction is this unit vector. So we'll calculate a unit vector and then we'll multiply it by some speed that we'll be able to customize, and that's how we'll work out where to fire our projectile. So that hopefully serves as just a quick recap of those vector concepts that we're going to need. So we're going to set up a projectile prefab and attach it to the enemy. So here's our projectile. I've instantiated one. I'm not working on the prefab here. I'm working on an instance just for the moment. So I want to see it in the world. I'm just aware of what I'm working on. I'm going to turn off is kinematic now because I want this projectile to be able to be operated on by the physics engine. We want to be able to set a velocity. And then once I'm happy that that projectile looks okay, it's got a damage caused here. Maybe not. Maybe we don't want the damage to be on the projectile anymore. Remember, we want to be able to give each enemy an ability to cause damage. So I'm going to make the damage caused by a particular instance of a projectile private, but I will serialize the idea of a float projectile speed. And each projectile could potentially come out at a different speed. So we'll customize the damage on the enemy, and it'll pass it through to each instance of a projectile, but the speed on the projectile. And then that means that over here we can have more than one projectile prefab. We've got this guy here now that we're happy has a default projectile speed of say 10. and then I'll overwrite the prefab with the instance. So this projectile has a default speed of 10 and that size. And then maybe I'll make myself another projectile as well now. So I'll just duplicate this with edit and duplicate. I'm going to call it fast projectile. And then this gives Rick a couple of projectiles to play with, and I'll give that a speed of 50, much, much faster. All right, so there are two possible projectiles in the world. This guy and this guy, they look very similar, but one is a projectile and the other is a fast projectile. Cool, so we have the projectile. Now we need to somehow associate the enemy with that projectile. So what we do is we need to make a space to do that. We're going to serialize field, a game object, because that's the easiest way to attach a prefab, and we're just going to call it projectile to use. And I'm not going to initialize it in this case to null. I'm just going to be conscious of whether or not I need to bother. You don't with a game object, it'll be null anyway. So the enemy now has a field for projectile to use. Now I'm going to set this up on the enemy prefab because I don't want to be messing around with these individual instances because Rick has set properties on them, remember? Speeds and stuff like that. You see this speed is bold on this enemy here. I'm going to call this enemy Boris. Why not? Just because I feel like calling him Boris. But he's got a speed, so I don't want to mess around with the instances. I'll go to the enemy prefab. And then on the enemy prefab, it's asking now, what's my projectile to use? Well, you go ahead and, in general, use a projectile by default. If you want a fast projectile, well, then when you've dropped your enemy in the scene, you come along and you say, actually, you use a fast projectile, right? It's as simple as that. And you can see that it's different to the default. All right, so that's that. We now have that. Now, the other thing that the enemy needs is a spawn point above his head. Now, I'm going to create a new enemy for this, again, because I don't want to mess around with any of the properties of the existing enemies. So I create a new enemy temporarily. I create a new child, call it projectile spawn point. Move it to where I want it above his head so that projectile can freely spawn and head off without hitting the enemy. And then once I'm happy with those properties, I can then overwrite the projectile prefab without affecting things like Boris's speed here. We want to maintain Boris's speed as an example of a property we don't want to overwrite. So that's cool. Now the average enemy, i.e. the enemy prefab, will have a projectile socket, but we need some way to find it in code. And again, we're going to use the inspector to do that. So we will expose ourselves a projectile socket. And I'll show you why that's useful, or remind you why that's useful in a minute. It's a nice soft reference. So projectile socket. On the prefab, once it updates, I can say, what's the projectile socket? Well, here it is. And what, of course, that means is if we decide to rename the projectile socket to something else, then all of these connections will stay. So all asset references and a projectile spawn point is a sub-asset of this dude. We want to be able to be changed in the inspector without breaking anything. All right, so new enemies now. If we look at this new guy coming out, he comes out with both a projectile to use by default and a spawn point to spawn it from by default. That's all good news. All right, so I think that is all the basic fundamentals we need, apart from we probably want to give one more property to this enemy here, which is that we want him to have a attack or damage per shot for now, and let's make that 10 or 9, something a bit weird, so that we can spot that it's different to the projectile's default damage. Remember, the projectile's got this like default damage of 10, and we're going to say, well, actually the enemy is going to give the projectile an amount of damage, all right, when it fires. So it's going to be your challenge to do all that. Let's go ahead and see what your challenge is, shall we? Spawn single projectiles. When the player enters the enemy's attack radius, I want you to spawn a projectile every frame for now. Don't worry about slowing that attack rate down. Just spawn a projectile every frame. You're already inside the update loop in enemy. The projectile should be aimed at the player's root. Do that simple vector maths if you can. And then the player should take appropriate damage on each hit based on the amount of damage set on the enemy. So Rick can go in and make each enemy more or less powerful. Okay, so go ahead, pause the video and see if you can get all that working now. All right, welcome back. So what we need to do then is start going to the enemy and start thinking about when we spawn a projectile, we're going to need a method for that. So void spawn projectile. And then it needs to do something. So firstly, let's just call the method from inside update. So it's going to happen every single frame. So to do slow this down. We don't need the print because it's going to be very obvious in a minute. So what do we do when we spawn the projectile? Well, the first thing we need to do is get a new game object back, or we could even go as far as getting a projectile back, actually, called new projectile, and it equals instantiate. Now, what do we want to instantiate? The projectile to use. At what position? Well, we want the projectile spawn point, or did we call it projectile socket? Yeah, we called it projectile socket, dot transform dot position, and then it needs a rotation with this particular signature of the method, so we're just going to use quaternion dot identity just to have no rotation on that projectile. All right, so what's it's concerned about? It doesn't want to instantiate a projectile as a game object and convert it to a projectile. Let's see if we can do a cast. And we can't, so let's just do it as a game object. And that's going to be fine for now. All right, once we've got hold of the projectile, the next thing we need to do, we've instantiated. Let's just make sure that this dude instantiates a projectile every frame now. When we're inside his radius, he does. You can see that happening above his head. He leaves this little snake behind. That's pretty cool. I'm just going to move the player outside his radius by default so that we can see it triggering on moving inside his radius next time we play. All right, so we're spawning a projectile. The next thing we need to do is to think about setting that projectile's damage. So we can say new projectile.getComponent, and then we can go and get the projectile component. Now, there's a bit of a question mark about performance doing this every single frame, but we don't want to optimize too early. Let's worry about the speed of this later if we need to. Okay, at the moment, we're quite happy. We're getting the projectile's component, and then from there, we should be able to set its damage caused. So to be able to set that damage caused, one thing we could do is we could say, well, actually, damage caused could be a public property of the projectile. It's fair enough for other classes to be able to set and get that, I think. I think that's safe enough because it's mainly going to be the thing that spawns it that does it. So I'm going to use this syntax, damage caused, and then you can say get semicolon, set semicolon. And that is a shortcut for setting you up a getter and a setter. All right, so from the outside, we can now say projectile.damage caused. You can't just put a setter because, well, firstly, we're going to want to get, and also it will tell you that auto-implemented properties must have get accessors as well. Okay, so if we say get set like that, now what we can do on enemy is we can just say projectile.damage caused equals, and then it equals the whatever damage for the moment, and later, of course, we'll make this much more RPG-like, but for now it just equals the damage per shot. All right, so we set the damage, and that's pretty obvious what it's doing. I don't even really need to comment it. The next thing we need to do is get the velocity. So we need to say that the vector 3, unit vector, not unity, unit vector to player equals what? Well, we need to know what the player's .transform.position is, and remember that's just going to be, it is like hips at the moment, minus the projectile spawn point, or the projectile socket's transform.position, and then what we want to do to get a unit vector is take all of that vector and just normalize it. Okay, because the size of this vector wants to depend on the projectile speed, which we actually haven't got yet. So let's just think, attack radius, chase radius. I'm going to move chase radius above attack radius. The idea here is we're going to try and get all this stuff kind of grouped together. So he has health points, chase radius, then attack. So the concept of projectile speed we could be tempted to put in here, but it's not really the enemy's business. He may have a damage per shot or a base attack damage. It's the projectile itself that needs to have the concept of projectile speed. And in this version of C#, I don't think we're going to be allowed to just do this, to put an auto accessor like this as a getter. It's going to probably complain at me about my language version or something like that. Yeah, not available in C#4. Please use language version 6 or higher. Right. So we want to make the projectile speed available to the inspector, but we also want other classes to be able to read it. Best bet here is just to make this puppy public. We're being very lenient with what we're making public, but there's no harm in making some things public. So we just say public float damage cause, get and set, public float projectile speed. Arguably, if you're going to make damage caused public, you don't need to put get and set because you might as well just get rid of that. It's redundant code, right? So we just have a public damage caused and a public projectile speed. We could mess around writing and making it serialized field, private, and then a getter for the speed, but let's just let other classes set this. So note other classes can set, okay? So we've got a projectile speed here as public. Now we need to just work out what the speed, what speed to fire this projectile at. So we need to have the new projectiles rigid body component. So let's just go and get the component rigid body. Not worry about get component being slow at this point until the performance profiler proves that it is. Dot velocity, and then what do we set the velocity as? Well, it's going to be the unit vector to the player times the projectile speed. Now we don't have a projectile speed here, so we're going to need to go and get one. The way to do that is to use this same new projectile get component call. In fact, I don't want to do that twice, so I'm going to take this out as a variable, and I'm going to say it's projectile component equals that thing there, just the once. That will come out as a class projectile. So I'll just type it in explicitly, and then I'll say projectile component dot damage caused is damage per shot. Then we go and get the unit vector to the player. We say that the projectile speed is the projectile component dot projectile speed. Okay, and then projectile speed doesn't exist in the current context. That's because I've never said what it was. It's a float, and I've declared it there and used it there. All right, so hopefully we can see what we do here. We instantiate the projectile, set up the damage, and then in this case we go and find a unit vector. We work out what the projectile speed should be, and then we multiply the projectile speed by the unit vector to the player to get the velocity that we want to set. Let's see if this all works, and then Rick can customize it. So there you go, it's firing at me, that's beautiful. And if I pause the video and step through frame by frame, you can see them being fired at basically at my base transformer. Is it aiming at the feet of the player? It's aiming at my feet at the moment. Let's not worry about the aim point for the moment. The important thing is that the player takes damage. So when we move in here, if we pause real quick and then go and find the player in the actual game, there he is, and then step forward in the game view, watching carefully, and when the first one hits, which is taking a while here because the player's on the move, when he eventually stands still, these things will home in on him, and when the first one hits him, he should take an appropriate amount of damage, and it looks about right. So good, he's taking a damage per shot. That's all working, and that's all the functionality we needed to get done in this video, and we have all the customization we need for this video. So I will look forward to seeing you in the next one where we'll slow down the hit rate.